Okay, so these are the things, these are 6 statements that we need to make sure we understand in the event that we are tasked with showing that a quadrilateral is a parallelogram. Okay? And they're in no particular order in regards to which ones are easy or determined. They're just the 6 that we talked about yesterday. It says both pairs of opposite sides are congruent. Okay? Both pairs of opposite sides are congruent. Understand what that means. Okay? It doesn't mean that all 4 sides are the same, right? It just says both pairs of opposite sides are congruent. So look at opposite sides, are they the same length? Okay? And then look at the other set of opposite sides and see if they are the same length, which might be a different length from the first set that's looked at. Okay? Looks like the question we just did. You might have 2 radical 5 and 2 radical 5. And then on the other side, you might have radical 13 and radical 13. But it does not mean that you couldn't have all sides being radical 13. Does that make sense, everyone? Okay. Skip down to the third one. Okay, so one pair of opposite sides congruent and parallel. Okay, that's a very useful theorem we need to know. If we can show that, quadrilateral then is a parallelogram. Skip down to the fifth one. Says both diagonals bisect each other. Both diagonals bisect each other. And then the 6th one says both pairs of opposite sides are parallel. And I put in parentheses that is actually the definition, right? Okay. And that's actually one of the easier ways of showing that a quadrilateral is a parallelogram in the coordinate plane. Okay. I went through them and I highlighted those statements 2 and 4 that we skipped in green. Those are true statements. Those are things that we need to know. I'm going to ask you about. But in the coordinate plane, it's really hard for us to deal with the measurements of angles. Okay, because we need some sine, cosine, tangent stuff. We need some just more knowledge about trigonometry to be able to do that. Okay, so the green ones are not going to be statements that we use inside the coordinate plane in the next couple of days. Okay, 1, 3, 5, and 6 are the ones that we're going to use. But if we look at 1, 3, and 5, they all talk about congruency, right? Okay, so if we're in the coordinate plane and they're talking about congruency, that means we have to find segment lengths and find distance. Okay, so those statements, whenever you see bisects each other, or wherever you see congruent, sides congruent, you have to find distance. Okay, and then if we look at statement 3, not only do we need to find distance, but we need to find slope because it says the lines have to be parallel as well. Okay, and then statement number 6. Says both pairs of opposite sides are parallel. That's the only geometry concept that we're interested in there. So parallel means slope again. So that statement would just focus solely on the slope formula. So when you're approaching a question, kind of like last night's homework, and it's just open-ended. First question last night said, find distances to show it's a parallelogram. Well, what if it just gave you 4 points to say show it's a parallelogram? Well, if it does that, then you have 6 options to go through to figure out whether that thing's a parallelogram or not. Okay? Hopefully you don't use the green options because that's really hard. But you have several different approaches you could use. Does that make sense? Okay? Some of them may be easier for you than others. Some of them might take a little bit longer than others. But it's your choice. All right? But you have to know your distance formula, slope formula, and know how to apply those. And even in the 5th one, you need the midpoint formula. All right? Does that make sense to everybody? That's the reasoning of why we learned these yesterday. It's because the task will be determine whether the shape is a parallelogram or not. And now you have to come up with data, numerical data, to argue why or why not it's a parallelogram. Okay? Now what's nice is you don't have to show all 6 of those. You don't have to show 2 of them. You don't have to show 3 of them. Once you can see that you have numerical data to prove one of those statements, then all 6 of those statements would be true. Does that make sense? Okay? So it's really nice. I'm a person, if they're going to ask me to find a parallelogram, quadrilateral parallelogram, I'm going to use statement 6. It's up to me. Okay? Because I think finding slope is a lot easier than finding distance, isn't it? Okay? It's just my preference. Okay? But sometimes they will kind of direct you, kind of like last night's homework did, in using a particular one of these things. Okay? So I want to do an example, and I'll give you a little bit of time to write this down. Your picture doesn't have to be, to scale. Doesn't have to be great. Okay. For instance, each one of those vertices is in a separate quadrant, right? So if I'm drawing this by hand on my notes or whatever, I would just make sure that 4, 3 is somewhere in the first quadrant. Okay. That 2, -2, somewhere in the fourth quadrant. The only reason I draw the picture, I want you to draw a picture just so we can organize our thoughts. Because there's usually going to be 4 things that we have to find numerically. And it would be nice to make sure that we find them without doing any extra unnecessary work. Or that, drawing a picture and organizing our thoughts actually allows us to maybe not accidentally only find 3 or 2 or something like that. Okay, so that's the only purpose for the picture. And I'm actually going to get rid of my axes just because it cleans up the picture a little bit for me drawing over here or writing over here. So, first thing I want to do, it said technique 1. Okay? Technique 1 here, when I want to show you, I'm just going to be focusing on just opposite sides. Okay? There's 2 approaches you can use. The first one is to use the definition. Okay? So technique 1, I'm going to use the definition of a parallelogram. Okay? What does the definition of a parallelogram state? Both pairs of opposite sides have to be what? Not by the definition. By the definition of a parallelogram, both pairs of opposite sides have to be parallel. Okay? So, if I'm going to try to prove this thing to be a parallelogram by the use of the definition, I need to see if the sides are parallel, right? So what math tool do we use to determine whether segments are parallel or not? What formula? Come on, guys. We're trying to find, we want to see if these lines are parallel, so we got to find slope, right? Okay, so slope is y2 minus y1 over x2 minus x1, or sometimes written this way. Okay, so I'll find a slope of all 4 segments. So I'm going to first find a slope of L to M. So when I do that, I'm going to subtract my y's. Okay, so I subtract that y and that y. What's that give you up top? L to M. 0. Okay? Do I do it, and this is just something you guys can think about, and then it alleviates a little bit of work. Do I care what the number on the bottom ends up being here?
Nope.
No, because 0 divided by anything is what?
0.
0. Now I say anything, and that might be a problem saying that because anything could incorporate 0, right? Can I take 0 divided by 0? No, I can't. Yeah, you can never divide anything by 0. So 0 divided by 0 is actually an indeterminate value. But in our coordinate plane, that will never happen because if I were to get 0 on the top and 0 on the bottom, it would actually mean that those 2 points are in fact right on top of each other. Does that make sense? Okay. So I don't care what the denominator is. It is going to be 6 here, I believe. 4 minus -2. But that eliminates a little bit of work for you, right? If you understand that concept. So slope here is 0. So slope up here is 0. And that makes sense. That's a horizontal line, right? Okay. I'm going to go to slope of ON, the side that's opposite. Okay. Subtract your y's. What do you get when you take -2 minus -2?
0.
0 again. And then I take 2 minus -4. It gives me 6. But the slope is still 0, right? Okay, so those 2 things have the same slope, so they are parallel. Would you guys agree with that? All right. Now I'm going to find the slopes of LO. Slope of LO. Subtract my y's. What's 3 minus -2? 5. And what's -2 minus -4? 2. Okay. Now just make sure that when you find these slopes, okay, I found slope of 5 halves. Make sure you get your signs right. It's a positive, right? Is this line moving from left to right up? And that's what positive slope should do, right? Okay. So slope is 5/2. Now I'm going to do slope of m to n. So 3 minus -2 gives you 5. And then 4 minus 2 gives you 2. So slope of m to n is 5/2. So did we just show then that those two things are parallel? Okay. So we've forced this thing, or we're showing this quadrilateral is a parallelogram by the definition of parallelogram. And that's the thing, guys, on the enforced exam. They're going to say, is this a parallelogram or not? And then they'll hit, so it'll be a question mark, and then there'll be the word Y with a question mark after that. Okay? And I know a lot of us have trouble with the Y part. Okay? That's what mathematics is about, not just being able to calculate, but being able to explain why. Okay? That's a parallelogram because the definition says that when both pairs of opposite sides are parallel, you have a parallelogram. Okay? Is that something we can do? I think that's the easiest approach because I think, one, you've done slope for an entire year last year. Okay? We've done it several times this year. It's a calculation that you can do quickly. Okay? But a second technique is to use distance. Okay, so if I go technique 2, find the distance of these segments. So remember distance, and this is just exactly what we did at the beginning of classroom with question 1 from the homework. And what's neat, I think, you might not think it's neat because it's math, but did you find y2 minus y1 when you did slope? Yeah. You find x2 minus x1 when you did slope as well, right? Yeah. So when you do slope, you're actually finding all the components that you need to find distance as well. Is that okay, everybody? Okay. So, if I'm finding the distance between L and M, there's actually two ways of doing it for a horizontal line or a vertical line, but if I just subtract my x's, what's 4 minus -2? Okay, 4 minus -2.
4 minus.
Yeah. Well, give me 6, right? Was 6 the denominator of my slope earlier?
Yep.
Yeah. And then subtract my y's, what's 3 minus 3? 0. Was 0 my numerator of my slope earlier?
Yep.
Yeah. Okay. So what's the square root of 6 squared?
36.
Gives me that, right? So what's that simplify to there? 6, right? That's a horizontal line, correct? When you have horizontal lines, all you have to do to find the distance is subtract the x values. 4 minus -2 gives you 6, right? Okay. If it's a vertical line, all you have to do is subtract the y values to find your distance. So let's now find the distance between O and N. So let's use the shortcut. It's horizontal, right? And the reason I know it's horizontal is because both points have the same y value. So if I subtract the x values, -4 minus -4 minus 2 is -6, right? But distance has always got to be what kind of number? Positive. So we take the absolute value and we get 6. Okay? If you guys remember early on, chapter 1, it would have been like the first week of school, we said distance on a number line is the absolute value of some x value minus the absolute value, minus some other x value. You take the absolute value of the whole difference. Okay? That's what we did right there to get that 6. So that's one set of or piece of data that we need to show for us to be parallelogram. Now we got those sides to be congruent. What do we need to know about the other two sides? What's the relationship between LO and MN that we need to show? Yeah, we need to show that they're congruent. Okay? So now this is not a vertical or horizontal line, so we have to use this formula here. If I go 3 minus -2, what's 3 minus -2? 5. Square that, right? Add to it. Now I'll go -2 minus negative 4 gives me 2. Square that. So I get 25 and 4, right? So that's root 29. And root 29 is a prime number. Or 29 is a prime number. Now I'm going to do the same thing for mn. So I'll go 3 minus negative 2. Gives me 5. I go 4 minus 2. Gives me 2. And I get root 29. Okay? So does that show that is the same as that? Okay? Now when I did these in red here, I actually did the y's first, right? Subtracted the y's and squared them, and then added to it the difference in the x's squared. Can I do that with addition? It's 2 plus 3, same thing as 3 plus 2? Yeah, okay? So generally speaking, your formula is always defined with x's first. But it could be y's, doesn't matter, because you're adding them together. So now we have shown that that is a parallelogram because there's a theorem that says in a quadrilateral, if both pairs of opposite sides are congruent, quadrilateral is parallel. Okay. Later on, next week, Tuesday, Wednesday next week, we'll talk about what can we do to maybe find or show up the things a parallelogram, maybe using diagonals and how the diagonals bisect one another. Maybe we'll use just one set of opposite sides. I think it would be maybe a little bit more efficient in this problem to maybe have gone through the approach saying, I know if this slope here is 0, right? If that line, that slope was 0, really easy to come up with. It's horizontal, right? I know if this slope here is also 0, so that's parallel. Could I have just looked at those two lines right there, those two segments, and said, well, one pair of opposite sides are both parallel and congruent? Okay? And maybe that's the approach I use there because with the horizontal lines, slope is really easy to find, and with horizontal lines, distance is really easy to find. Okay? So you've got a collection of 6 things that you can use. Okay? Probably 4 things. You don't want to use the angle stuff. But you got 4 things, 4 techniques you can use. And if it's an open-ended question, use any one you feel comfortable with. If they direct you down a certain path, then you got to make sure that you're able to do all those things. You can do slope, you can do distance, you can find midpoints if you need to. Okay? So that's kind of the course that this is going to take as we move forward. Eventually, in the next couple days, like I said, we're going to continue to work with parallelograms.